What we're looking at in today's lesson is a process called synthetic substitution. It's going to be a way to evaluate a function at a given point. So first what we want to do is we want to take a look at just evaluating a function. So we have the function f of x equals 3x to the fourth minus 5x cubed plus x squared minus 4x plus 1. And the instructions say find f of 2. So what it's asking us to do is take the value of 2 and replace every x that we see in the function f of x with a 2. So we're going to have 3 times 2 to the fourth minus 5 times 2 cubed plus 2 squared minus 4 times 2 plus 1. When we simplify this, we end up with 2 to the fourth, which is 16 times 3 is 48, minus 8 times 5 is 40, plus 4, minus 8 plus 1. All of this will end up simplifying to 5. So for an input of 2, we get an output of 5. We're going to take a look at a different way of evaluating this function at 2. The process that we're going to do is called synthetic substitution. And there are two steps that are involved. First, we're going to add down, and then we're going to multiply diagonally. And we're going to continue to repeat these steps until the process is finished. One of the things we need to do is we're going to have to figure out what goes where. So in our function, you'll notice it's the same function we just used, and I'm asking to find f of 2 again. You might notice that we have the 2 is going to be our input into our function. I'm actually going to put it in the box in the upper left hand corner, and that number is actually going to be our multiplier every time. So out beside there I put that it not only is it the input, but it's also the multiplier. So when we talk about multiplying something, we're going to be multiplying by 2 for this problem every single time on this particular example. The other piece that I have is a place where we're going to start peeling off the coefficients. So our coefficients are 3, negative 5, positive 1, negative 4, and positive 1. So in line with the 2 that we put before, we're going to list out our coefficients of 3, negative 5, 1, negative 4, and 1. This is the setup. So our setup is actually complete now, and now we're going to go through the process of synthetic substitution. The first thing we're going to do is we're going to add the 3 straight down. There's nothing to add it to, so we're just going to drop it below the line there and write the number 3. Our second step is to multiply diagonally. So every time I multiply, I'm going to multiply diagonally, and I'm going to use the multiplying number that we talked about. So I want to use the 2 as a multiplier, and that's going to be every time this problem, when we multiply, we're going to say times 2. So we have 3 times 2, which is 6. That's the multiply diagonal step. And now we're going to add down. So we're going to take the negative 5 plus the 6 that we just found, add those together, and we end up with 1. After our add down step, the next step that we want to do is we want to multiply diagonally again. Again, we're going to use our multiplying number of 2. So the 1 that we just ended up with, we'll multiply by 2, diagonally heading up. So 1 times 2 is 2. And now we're ready to begin again through the process. We'll add down, so the 1 above plus the 2 makes 3. And now we're going to multiply again diagonally. So we're continuing to add down and then multiply diagonally by 2 because that's my multiplying number. So we have 3 times the 2 is 6. And then we want to go ahead and add down. Negative 4 plus 6 is a positive 2. The next step is multiply diagonally. The number we're going to multiply again is 2. So we have 2 times 2 in the diagonal direction. Gives us a value of 4. And then we'll add down again. So 1 plus 4 is 5. What you'll notice is, in the dotted box that I have below, that value of 5. It's not a mistake or a coincidence. That value of 5 is exactly what we had on the previous slide whenever we plugged 2 into the function and evaluated it. So we actually have two ways of evaluating a function. One is directly plugging it in, and the other one is through synthetic substitution. The answer to plugging 2 into synthetic substitution is the value that occurs in that dotted box at the very last step. The process again is add down and multiply diagonally. The value that we're wanting to plug in goes in the box in the top left. That's our multiplying number. It's the value that we would have plugged in. And then you'll notice also that we had our coefficients spread across that top row. We're going to take a look at another example. So we have g of x equals x to the 4th plus 3x squared minus 20x minus 1. The instructions here say find g of 4. 4 is our input, so that's the value that's going to go in the box as our multiplier number. So on this particular problem, every time we say we're going to multiply, it's times 4. As we write down our coefficients, I have 1x to the 4th. And then the next question is, how many x cubes do we have? Well, there aren't any x cubes present, so we need to fill that space with a 0. 3x squareds, negative 20x's, and negative 1. So one of the keys, and this problem is slightly different than the last one, is that if anything is missing, if it's missing a term along the way, we actually have to put a placeholder in, and in this case we had 0x cubed, so we chose to put a 0, or we had to put a 0 in for the x cubed place. That's going to be something that's important to remember as you go through the process. It's always a good idea after you write down your coefficients to look back and see if you had any missing zeros. Okay. Our process says to add down, we add 1 down. Our multiplying number is 4. So when I multiply diagonally, I'm going to multiply by 4. So 1 times 4 is 4. We add down, so the 0 plus the 4 gives us 4. We're going to multiply by our multiplying number. So the 4 that we had times our multiplier of 4 is 16. We'll add the 3 and the 16 down. Makes 19. Our multiplier of 4 times the 19 gives us 76. We'll add down negative 20 and 76 is 56. And we're going to take our 56 times our multiplying number of 4. So 4 times 50 would be 200, and 4 times 6 is 24, so we have 224. And we add down again, and whenever we reach that final column, we get 223 in our dotted box there. And our claim is that 223 equals g of 4. So if you plug 4 into the function g, you should end up with the number 223. So we'll go ahead and give you just a second to take a look at that. Plug 4 in to the function g. You can use a calculator if you need to, and see what you end up getting. Okay, hopefully you found the same answer of 223. What we're going to do is we're going to take a look now at why this is true. So we're going to take a look back at our original function that we had, the f of x function that we started with. And I'm going to talk about factoring, but my problem on this is not to factor the problem, but to factor it a certain way. We're going to set aside the constant 1 for just a second. Look at the remaining terms. All of them have an x in it. So we're going to factor out the x. When we factor out the x out of those remaining terms, we're left with 3x to the third minus 5x squared plus x minus 4. So this is not in order to do synthetic division. This is actually just to describe where it came from and why it actually works. Okay. We're going to do the exact same thing again. We're going to set aside the plus 1 that we had before. We're going to copy the x that we had factored out. We're going to have to use a lot of parentheses here, trying to keep track of where everything is. And the constant term that I had inside of negative 4, I'm just going to set aside a little bit. So out of the three terms, 3x cubed minus 5x squared plus x, I have an x in every single one of those. I'm going to pull it out. Notice it's out in front of the black parentheses there, not all the way out in front of the red. And so I'm going to look and see what I have left after pulling the x out. I have 3 x squared minus 5x plus 1. I'm going to do this process a couple of more times. I need to make sure that I copy down correctly the x's that I've already factored out, the constants that I had already set aside, the plus 1 and the minus 4. Make sure I use all the parentheses that I was using before as well. And now I'm going to set aside the plus 1 that I had inside the parentheses there. And now the two terms that I have left, the 3x squared and the minus 5x, each of those have an x in. So I'm going to pull an x out of front of those, factor that out. When I factor out that x out of those two terms, I'm left with 3x and minus 5. Okay, I'm going to do this process one more time just so we can get all the way to the beginning step so we can kind of understand what we have. It'll look kind of weird whenever we do this last factoring. It'll look like there's not a whole lot there to do. So I need to make sure that I copy down all the constants that I factored out or set aside, and then all of the x's that I factored out, and making sure that I keep track of all of the parentheses that I'd used. Now I have a 3x and a minus 5 inside those green parentheses. We'll set aside the minus 5 constant term. And all I have left is a 3 and an x. It'll look a little weird, but what I do need to do is I need to actually go ahead and factor out the x out of 3 times x. So I'm just going to put that in front like I'd been doing. The only thing I had left there was a 3, so I'll copy that down as well. So in the end, what we have here is, you'll notice each of the constant terms, the 3, the negative 5, the plus 1, the negative 4, and the plus 1 all came from the coefficients of the original function. And so what it's asking me to do is it's asking me to take an x value. In this case, our x value was 2. So I dropped the 3 down and multiplied it by an x of 2. Added it to a negative 5. That was the adding down step, adding to the previous coefficient. multiplying that result times the 2, adding to the coefficient of plus 1, that's the adding down step, taking that total times a 2, adding that quantity to the negative 4, there's my add down again, to the coefficient of negative 4, multiplied all of that times 2, and then the last step was add 1. And the coefficients that we had were the 3, the negative 5, the plus 1, the negative 4, and the plus 1 from before. Our multiplying number is represented here as x, and that multiplier number in our problem was a 2. So it followed from an add down of 3 and a multiply of 2, and then adding the next coefficient of negative 5, multiplying by 2, adding the plus 1 coefficient, multiplying by 2, going through and taking that total and adding the negative 4, multiplying by 2, and then that last step of adding the 1 back in. So those coefficients come into play there as adding to the previous total, and each time we're multiplying by the x, which was a 2. Okay, we're going to take a look at one last problem here. On this last problem, we have h of x equals x cubed plus 2x squared minus 4x minus 2. And the goal here is to find h of negative 3. And we're going to do this process again by synthetic substitution. So I have the grid set up for you. See if you can find where all of the numbers go, and then go through the synthetic substitution process. Okay, our input was an input of negative 3, and that's going to be my multiplier each time. So we put that in the box in the upper left. We copy down all of our coefficients, 1x cubed, 2x squared, negative 4x, and negative 2. We always want to go back and double check and make sure that we didn't have any missing zeros. And now we follow our process of adding the 1 down, and every time we're multiplying by negative 3. So times negative 3 is negative 3. We'll add down the 2 and the negative 3 to make negative 1. Multiply again by negative 3 diagonally. Adding the negative 4 and the 3 makes negative 1. Multiply by negative 3 again, makes a positive 3. And when we add down negative 2 plus 3, we get 1. And our claim is that the answer of 1 is the exact same thing we would have received if we had actually plugged negative 3 into the function. So h of negative 3 equals 1. So take a second and see if that actually worked out.